All righty. Hello, everybody. Good morning, good afternoon, depending on where you're joining us from. My name is Paul Lacey. I'm the head of product marketing here at Ascend.io. Welcome to this session of Build with Ascend, where you can join and drop in and watch us working with Ascend, doing real life experiments and building real life things and talking about how we do it. So I will just give a couple more minutes for everybody to join. But while we're waiting, I'm joined by my colleague, John Saltzman. John is a product engineer here at Ascend, and he's going to be walking us through what it means to build on data planes in Ascend and kind of how that will impact your experience and how you can unlock tremendous levels of productivity by being able to do this. Just give a couple more seconds. And in terms of housekeeping items, we should cover. So this session is being recorded. We will publish this online when we're done. So you don't need to take frantic notes. You can kind of hang out and watch what we're doing. And we will be answering questions live. So one of the benefits of joining us live is that you can interact with us. You can ask us questions. So please do put those questions into the Q&A as we go through the demo today. And we'll be taking those questions after the session. So please feel free to just ask away. This is kind of an Ask Me Anything style format. So if you've got questions about what we're showing or questions about other things related to building data pipelines, that's what we're here for. So without any further ado, I think we've got a decent number of people on the line here. So I'll go ahead and hand it over to John Saltzman. John, please take us away.
Thanks, Paul. Nice to see you all here today, and really excited to talk and go a little bit deeper on the concept of data planes. This is kind of one of the first times we're actually getting to really go deep and talk about this publicly. This is a relatively new feature speaking in the lifespan of the Ascend product. So without any hesitation, let's just jump right in. What does it mean to build with Ascend with data planes? So actually, I'm going to kind of give you a demo and slide sandwich for this presentation. I'm actually going to take you straight into an Ascend environment because I'm so excited about this feature. I want to show it to you first, and then we'll talk about behind the scenes what's actually going on. So here we're actually in one of our demo environments. And if you're a current customer of Ascend, or if you know the Ascend product, you might be surprised to see something here. We have what we call our data services. Our data services are like a logical container for data flows. And we have different data services here that are running on different technologies. So you can see there's one here that has the little BigQuery logo for Google BigQuery. We've got one running for Databricks, which got the Databricks logo. We've got one running for Snowflake, and we've even got one running for Spark. You might say, wait a minute, what's going on in this environment here, like in this Ascend environment? Well, these are all data services that are running the data pipelines that are inside the data flows on different data planes. We'll talk a little bit more about what the concept of data plane is in a second, but I wanted to show you as well, like when you look at a data plane, like within the product, what's different about it? I mean, from the outside, it looks pretty much the same. The logo on top is different, but other than that, like what's actually different? So if we go into one of these data flows, we have our taxi cab demo that we like to use a lot for different examples. So you're inside a data flow now. And again, if you've seen Ascend before, if you've seen any of our other presentations, this part looks pretty familiar. These are our declarative primitives, read connectors, transforms. Here we have some data feeds, things of that nature. But what you can see is different about this particular one. I'm in a BigQuery data plane. I do have some different functionality over here in my build panel. I have BigQuery SQL functionality, and I have a BigQuery merge tool, which I can use. I still have Spark sitting over here as well. And if I open up one of these transforms, you'll see that in here, I have my BigQuery SQL syntax statement. So in this particular one, I have technology from BigQuery accessible to me. If I go over to the main screen again, and I jump over to, for example, the Databricks one, and I look at the same New York City taxi cab demo, you'll see it's a little bit different. I have a little bit different technology available to me. I have my Databricks SQL and my Databricks merge, and I still have some PySpark, except this one says it's running PySpark on Databricks because Databricks supports PySpark. If I jump over to one of my other data services in yet another data plane, Snowflake, and I go to my, let's say, taxi cab demo again, you'll see I have my Snowflake SQL, Snowflake merge, and Snowpark, which is essentially PySpark running on Snowflake within the Snowflake environment. And I even have one additional one here. So we'll go down one little bit more, which is a Spark one. So this is an open source Apache Spark. And you can basically see here, I have my Spark SQL and my PySpark available to me as well. So I have different technologies. I have different data planes all running in the same Ascend environment. And of course, what you can't see here, and this is where we'll get into the slides, is, well, okay, I have all this different technology, but what's going on underneath? So let's get into the slides really quick and start exploring what's inside. As you know about Ascend, this is our kind of our picture of our ecosystem, the sources, the destinations, the experience that you were just looking at, which is the build plane, where you build with the ascend primitives, your ingest, your transform, your orchestration, your sharing primitives, running on top of your data cloud, your data plane, so your Snowflake, your BigQuery, your Databricks, and so forth, running on top of your public clouds, your AWS, your GCP, and your Azure. So this is the story of the platform of Ascend that runs your intelligent data pipelines. But let's break this down a little bit further. So now we're going to start zooming in, if you will. If you're an engineer and you like the concept of sort of different layers of the stack, we're going to start zooming in on the stack and breaking it down. So let's move this over to the side and let's kind of spread it out and give it some room to breathe. And let's start looking at the planes that are inside these different layers. So, architects, engineers, we like planes, right? I'm not talking about airplanes, I'm talking about architectural planes. Within Ascend.io, the platform, you have seen some of our other materials where we talk about the ops plane. This is where you have your observability, where you have your management of the platform and things of that nature. The build plane, which is where you have the user experience for building, where you actually see the DAG view, the data flow view, where you actually see how everything flows. That's what we were just in. And then the control plane. And this is really the proprietary engine that Ascend contains for orchestrating data movement between data clouds, between data sources, making sure your data flows, execute in the right order, handling when things, fail, and recovery automatically, all these other different things. So the scheduler, this is the control plane. This is the brain of the Ascend platform that enables a lot of the automation in the platform. We're here today to talk about data plane, which most closely links to those data clouds on the left-hand side. And then, of course, at the bottom, you have your cloud plane, which is your cloud infrastructure that this all runs on top of. If you are a fan of the Scooby sandwich and you're looking at these layers and thinking, boy, that looks like a Scooby sandwich to me, you're not mistaken. I don't know. Engineers like Scooby sandwiches, lots of layers, right? So let's talk a little bit more and zoom down into that data plane now. What is a data plane? In Ascend, we think of the data plane as kind of being two components put together. It's, in terms of data platforms today, you've heard a lot about the separation of compute and storage. Right. So then when you want to do work, though, you have to combine those two things together to actually do any kind of work. You need storage and processing and compute. So to us, a data plane is made up of a combination of compute, which is the engine that runs your pipelines. And then there's the storage, which is basically where the storage for like intermediate results and metadata go for your platform, for your pipelines that are actually running. So we break a data plane down into the compute and storage. Of course, as I mentioned, the three big ones here, your Snowflake, your BigQuery, and your Databricks. Of course, what are those data plane native technologies? We kind of talked about it, but this is a good point to kind of call out. Like we already showed you kind of maybe the compute technologies that are involved. So Snowflake, you saw Snowflake SQL, Snowpark. For BigQuery, you saw BigQuery SQL. For Databricks, you saw Databricks SQL, PySpark. And for Spark with Iceberg, which is one of our other engines, you have Spark SQL and PySpark available as well. What we didn't talk about yet was what was going on underneath, right? Where's the storage going? So if you're on the Snowflake data plane in Ascend, then your storage is actually Snowflake tables. You ingest data into the platform, it goes into Snowflake tables. So there's no proprietary Ascend storage or anything like that. It's in a standard format in a Snowflake table, standard Snowflake table. You can literally connect to Snowflake and see the tables that we ingest for those intermediate results. Same is true for BigQuery. When we ingest data into BigQuery data plane, it goes into BigQuery tables. Same is also true for Databricks. We go into Databricks managed tables, which go in Delta format as managed tables into Databricks and have a table basically on top. And if you use our Spark with Iceberg, underneath it actually uses blob storage to store Iceberg files, where Apache Iceberg is essentially an advanced version of, like, let's say Parquet with a bunch of other functionality around it so that you can do transactions on top of that data that are atomic. So you can get a whole bunch of additional functionality like time travel and things like that. So underneath there, it's actually Iceberg files and blob storage that then usually has an engine on top that makes it look like a table to you when you consume it. So these are the storage aspects that are underneath these different data planes, and then the corresponding compute that goes with it and those native technologies. Now, if you're familiar with this picture, you've probably seen it 1,000 times. You have sources and destinations, and then data has a life cycle that it goes through. Some people call this maybe the raw, the staging, the modeled layers. Some people might call it bronze, silver, and gold if you're using the medallion architecture. But these are basically different stages that your data goes through as it becomes more and more enriched, more and more modeled from sort of the raw, maybe transactional or raw, event stream sources, things like that, into those modeled things that people use for analytics and other purposes, putting the data together to do reverse EL and feed it to other systems and those kinds of use cases. So this shouldn't be anything new to anybody. The point is there are materialized intermediate stages of data. So when we look at a declarative data pipeline on Ascend, So on top, let's look at ascend as being a plane, if you will, simplifying it. And here's those UI representations of those declarative components. Here, just as an example, a read connector, transform, and a write connector. So the read connector is an ingest component. The transform is obviously transform, business logic, mashing your data, wrangling your data. And the write connector is part of the sharing functionality. So it's about pushing data out to those destination systems from what you have ingested and transformed. So here on the bottom, you can see that this directly correlates to the data plane. And we put push down and orchestrate here because we're trying to indicate to you that when Ascend orchestrates and executes your pipeline that's running on a data plane, we actually push down that processing into that data plane's engine and into that data plane storage. So this is really, really important because unlike a traditional ETL, ELT, data processing, data pipeline tool, which brings the data into its own engine and data flows through, we don't actually do that. We actually keep the processing and the data as much as possible in that data plane. So ingest the data from the source into that intermediate, maybe raw or staging tables. Run that transformation code, whether that's SQL or in the case of like Snowflake, running Python code in the data plane platform, like say in Snowflake. And then materializing the result of that intermediate result, that staging table, that model data inside of the data plane as well. And then potentially writing it out to some destination. So as you can see, that Ascend is kind of just like let's say a virtual layer orchestrating what's going on in the actual underlying data plane engine and taking advantage of those native capabilities of that platform. So, we don't have a ton of proprietary processing or storage or anything like that. We're using those platforms' capabilities to do the actual pipeline execution and materialization of the data. So with this, you can start to see a pattern emerging. And I guess you have to ask you, what does that pattern sort of look like? It's a distinctive shape, and yeah, it's still a plane. Architects love planes after all, but it starts to look a little bit like what some might call a mesh. So if you are thinking about using Ascend to enable your data mesh strategy in your organization, here's the technological side. Here's a way to start thinking about all these different data planes working together, being what they're doing, and the pipelines running them being orchestrated by the Ascend platform. And of course, you're hearing a lot in the industry about data mesh and data fabrics and things of this nature. So this is to sort of start to tease you with, this is how you can start to enable that kind of a strategy for your organization. Much more to come on this as well. So with this, I'm actually going to flip back over to the demo, and let's look a little bit more at kind of what's going on here. So I have another Ascend environment where I explicitly kind of cut down what you're looking at so I could simplify it and kind of show you a little bit what's going on here. And at the moment, I have just 2 Ascend data services set up. I have one for BigQuery and I have one for Snowflake. So I can go in here and I can create new data services as well. So I could come in here. Let's say that, let's actually look at it for a minute. So in your organization, if you're an organization of any particular size, even small organizations, I've seen this pattern out as well, especially companies that are building microservices and are kind of breaking out responsibilities internally for both their operational business processes as well as their application functionalities. You'll have this emergent concept of domains and bounded context if you're a fan of domain-driven design concepts, which definitely come into play with data mesh concepts. You'll have this concept of domains. And domains typically are a concept that can even go across bounded context. A bounded context could be like a department. It could be a team. So you have these concepts of domains, data domains in this case, like, for example, the customer's domain. Now, customer is a very generic term and can be misinterpreted. It's probably not a great example because customer could mean something to everybody else, but it's something everybody's familiar with. So we use it as an example here. So you have a customer's domain, you have an orders domain. This is broadly applicable to all kinds of different organizations: order management, customer management, and so forth. So we could come in here and we could continue along this concept. Maybe if order management is your backend order management processes, maybe you have a sales order management process as well. Maybe the sales order management is done by a particular team in your organization. Maybe that team happens to use, I don't know, Databricks for all of their data pipelines that they build to and from all your different sales systems in your organization, right? So I could come in here and say, let's create a Databricks data service. And basically, here you go. You see, I've got my Databricks one. Maybe I have another one, which is my, and this is a little bit of a made up example, but you get the general idea. Maybe I have, an inventory team that's managing my inventory. Maybe for whatever reason, they have their data in, or they want to use like data lake storage, and they have their data in Spark and Iceberg. So we'll say, okay, inventory data, and it happens to live on top of this data plane, Spark with Iceberg. So we'll create one of those as well. So now you have that same pattern you saw at the beginning, which is I've got all these different data services with all these different data planes running. Right? I've got that sort of that mesh effect starting to go on, or that fabric effect. Of course, this is just like one of each types. I can create, many data services. I can go in here and I can create yet another one on top of Snowflake, for example. Maybe that one, maybe this is my team that manages my web properties, and maybe we call their domain visits or impressions or something like that for web traffic. So maybe we even go and create another one for Snowflake. So now I've got 2 Snowflake data services, but maybe these are different teams that are managing each different part. So now let's take a moment to very quickly just kind of show you a little bit of what goes into configuring a data service and a data plane. We just created a bunch of them, right? So if I go into a data service, you'll see that I have a data plane configuration. Here I went into the BigQuery one, and each one uses a connection. So this is a standard ascend concept. It's a connection to a data source. You wire it up to a connection, and then you have some settings for each of those different data planes that you can configure for each of those different data services. This is actually something for existing customers that might be a little bit new, because this lets you assign different groups of resources depending on the technology you're using to each data service. So especially in a technology, for example, like Snowflake, where you have the concept of warehouses, which are essentially compute, and you can split workloads out across different warehouses. If I look at the data plane configuration there, I can have a connection to Snowflake, but I can actually use different warehouses for different data services. So if I have different teams or different domains and they have different budgets within my organization and they're allowed to use these different technologies, this is a way that you can start to split that workload out over different warehouses and so forth. And I have a bunch of different capabilities here about how I name things that get materialized into that data plane, the settings for when I materialize things there, how do I clean it up, and so forth. So these are some of the settings. A connection is the big one. As soon as you create a data service and you create a data plane configuration, you have to connect it to something where it will actually execute the logic and store the data. So if we go back and we look at maybe this customers one for a second in BigQuery, right? So what's really cool about this is here I'm ingesting data from BigQuery, and I happen to use a feature we call registered tables. That's for another day's demo. But the point there is a registered table called my tables. I don't have to actually ingest it. It already lives in BigQuery and I already have access to it. So I didn't actually ingest the data. I'm just pointing at it in my data flow. The transform, I actually ingested it. And so here there's a copy of this data that lives inside of my actual BigQuery storage as a table. And then here I have a data share, and this is part of the sharing capability. Now, if you're familiar with Ascend, you might have heard data feed. Data share is the next generation of data feeds. This is in private preview right now. If you're interested in it, you can actually test this functionality out today. So we highly encourage you, talk to your salesperson, contact our support people if you'd like to try this on your Gen 2 environment. We can enable this feature in private preview if you'd like to try it out. It does replace data feed technology. So if you want to try it out, make sure you understand that particular part of it. But it is available in private preview today. And telegraphing for next week's demo, we'll do a little bit more demo of data shares and what that actually enables, because it's a key enabling feature for an Ascend for data mesh strategy. So when we run this data pipeline, because both of these components are in BigQuery, the processing happens completely, for the most part, within that data plane. Of course, we do have to ingest if we're using an external data source. Let's go over to, actually, I think I used an internal one for Snowflake too. I did an internal one for Snowflake. But if I were ingesting from an external data source, I would have to read that data from the external source and write it into my data plane storage, right? If I was materializing it from an external source into an internal one. In this case, I happened to use data that already existed in those data planes, so I didn't have to ingest anything. However, the transforms, the data is already in that data plane. So when the transform runs, the data doesn't have to leave. It basically just gets processed in place. We run this Snowflake SQL, for example. Here I'm doing a simple calculating total cost, quantity times price. This transformation happens in that data plane. This data set gets materialized in Snowflake, and then I can share it out to other consumers within the Ascend platform. So let's see if we can do some quick ingestion here. So I have this visits Snowflake data service data plane. I'm going to go into my admin section, and I have a connection that I already registered here to a GCS bucket, which has data in it. So here I'm going to take some data that's in GCS, and I'm going to ingest it into Snowflake. I'm going to share this connection with my visits data service so that I can access it over there. So now if I go here and I create a data flow, let's call it, I don't know, visits data. And I'm going to create a standard read connector, plain old standard Ascend primitive read connector. And I'm going to use that GCS bucket. Now in that GCS bucket, I happen to have a little, this is just a real simple sample file. Obviously you'd probably have the data partitioned or whatnot, but I have some sample website traffic visits data. And of course this data would be generally pretty huge if it was actual web traffic. I'm just doing a short example that I can actually run here, like in an actual demo. So we'll go ahead, we'll ingest that, we'll hit generate schema here. We'll see what's in those visits data real quick. My Spark cluster probably went to sleep. Here we go. There it is, right? So here I have some data. Oh, look, I have a customer ID and a timestamp, an IP, and what URL they were on, and so on. This is all made. This is all fake data, by the way. This is none of it's real customer data, so don't worry about that. We are super security sensitive, obviously, about data at Ascend. So we'll go ahead and create that. Anyway, and then basically there you get the general idea. You have the visits. We'll oh, I didn't share my Snowflake connection with it. So I mentioned before, when you create a data plane, you have to basically connect it to a connection, right? So I'll come down here, I'll share my Snowflake connection with that visits data service. I'll go back over to my data service, go to my data plane configuration. I'll wire up that connection. So now my data service is enabled with a data plane. I didn't do that first, that was my mistake. So come in here really quickly, we'll reset this. And then this should start running in a second. Oh, look, I don't have enough privileges. Oh, the demo gods weren't with me today. I needed to go set up some privileges. Point being, I was trying to ingest some data from my BigQuery GCS, or my Google GCS storage into my Snowflake data plane. So you get the idea. And then once I have this ingested from all these different sources, the idea is that, okay, now I've got different teams, maybe different technologies, all in one Ascend platform. And as I said, telegraphing what's coming, I could then create data shares and maybe start to share that data across the different data planes. So that's all I was planning to demo today. Keeping in mind, this is kind of where we're going with things. So I'd like to open up now. I didn't leave a whole ton of time for questions. I can talk about this technology for hours, obviously. So 30 minutes is barely sufficient, but I'll turn it back over to Paul. Paul, any questions?
Hey, thanks, John. That was super helpful. And yeah, I mean, I learned a lot just sitting in on this. I'm really looking forward to hearing what our friends that are joining have to say about it as well, and anybody watching the recording. But we do have some questions that came in, and I don't know if we can get to all of them, John, but we'll make our way through this list as best we can. And then any other follow-up questions, we'll be happy to reach out to folks offline and make sure you get answers to your questions. But so some of these probably came in during your presentation, John, so we maybe touched on them, but just for the sake of making sure that we answer everybody's questions here today. So somebody asked, are the data planes connected in Ascend?
Yes. So the Ascend orchestrates the data movement between the data planes themselves. So they literally, we are orchestrating the movement basically between them. So in that respect, they're loosely connected. You can, as you know, intelligent data pipelines, the idea it's a pipeline, data is moving through it to go from place to place. So we are literally orchestrating the movement if we are sharing data between data planes, which again, that's part of the data shares functionality. And we can actually talk about how that actually works in our next demo. But you can think of them as being logically connected. They may not actually be physically connected. They're connected through Ascend, basically. Ascend is creating that network of connectivity between these different data planes.
Awesome. Thank you for covering that, John. Yeah, super clear. I'm going to combine two questions now because they seem somewhat similar. So I'll hit you with both of them, John. You can maybe talk about the nuances here. So somebody asked, how does Ascend handle compartmentalization between data planes? That's a big word. I'm glad I was able to say that all at once. And somebody else asked, do you have a VPC or agent architecture for security/governance, which feels like it's in the same vein of compartmentalization? So there's that big word again for you, John.
Absolutely. Well, as you can see in my demo, when the demo gods weren't with me, there was a security permissions thing. So the data planes themselves have their own security layers to start with, right? So you have the native security layer of the data plane as one layer of security, first and foremost. Secondly, in Ascend, the data services also act as a sort of isolation or security layer. We have our own security layer in the platform as well, role-based access control, who can access which data services. So there's an additional layer of security that is like essentially logical like layer in Ascend as well on top of that. And then when you start sharing data across these different data planes, there as well, data shares themselves have an additional security layer for which you can specify which data services have access to which data shares and so forth. So there are several different layers of security, all the way down from the actual native data plane security, all the way up to these layers that are within the Ascend product as well. And then this concept of an agent-based architecture or not, Actually, no, Ascend doesn't have any particular agent-based architecture. We're not running an agent in those data planes. We're connecting to them and we're orchestrating data movement between them. So we can take advantage of technologies in that platform, but Ascend is basically working those technologies from its own external, server that's running. We're not necessarily running anything as an agent in that particular data cloud or things like that.
Makes total sense. Yeah. And there's another question, which is essentially along the same line. Says, does all data flow through your centralized SaaS platform? Some folks that are familiar with some of the maybe modern data stack style architectures, the data does have to flow through the SaaS platform itself. And so then you have to worry about security and governance and what region of the world that cloud zone is running in and stuff like that for governance and whatnot. But and sovereign data sovereignty concerns. But yeah, so as you said, John, totally, we operate on the data planes, but the data itself stays within those data planes. And then we do also, I believe, John, right, have a dedicated private cloud deployment of Ascend. So essentially you get to deploy it in your virtual private cloud and you can control which region of the world it's running in. And it's highly secured. You can put it behind your own firewall, all the great stuff that folks are looking for all that security as well.
Yeah, exactly. As you can imagine, when we can work within one data plane, we will push all of the processing and the data movement as much as possible, depending on what you've built in your data flow, to that data plane. So the data stays in there. Of course, if you want to go across, now you start going across boundaries, but we have security layers for that when you start crossing over those things. In that case, you have to go through something. But as you rightly pointed out, because we can deploy in your environment as a dedicated option, if all that networking between those data clouds and the public clouds is happening under your control, then you basically have full control of like how the data is flowing. It doesn't necessarily have to flow through a public cloud SaaS. We have two offerings. We have a kind of a normal cloud offering, multi-tenant, serverless, and so forth. But if you have higher security concerns, you go for a dedicated environment, and then all that traffic between those data planes and your cloud all happens under your control. So you can have whatever you need to orchestrate for your particular needs in that case.
Excellent. Well said, John. Well, super. Well, thanks everybody for joining and for the great engagement, great Q&A. We could stay here for hours, I think, but that's why we do this every week. So please do join us again next week for the next chapter of this series. We'll be talking a little bit more about how you share data between your different clouds and what that looks like to create a data product in Databricks and start consuming it in Snowflake and things like that. So a little teaser for what's ahead, and we look forward to seeing you then. But have a great rest of your day, everyone. Cheers.
Nice to see everybody. Thanks for attending.